Good day, so this is our fourth laboratory experiment entitled Ohm's Law. The objective of this experiment is to verify the Ohm's Law principle. The apparatus that was used is the PhET simulator Circuit Construction Kit DC. In the diagram in the PhET simulator, under the lab category, there are a couple of tools that are available. There is a wire, battery, light bulb, resistor, and a switch on the left side of the screen, while there's a voltmeter and ammeters on the right side. In starting to form the circuit, we started to put together the resistor, wire, battery, switch, and an ammeter. We also added to the diagram the voltmeter, the two wires connecting at the both ends of the battery. And there is also an option to change the resistance of the resistor and the voltage of the battery by clicking the resistor to change the resistance and clicking on the battery to change the voltage on the circuit. As a result, the current of the circuit will be given. Trial 1 has a resistance of 3 ohms and a voltage of 13 volts with the experimental current of 4 ampere. Trial 2 has a resistance of 16 ohms and a voltage of 13 volts with the experimental current of 0.81 ampere, while Trial 3 has a resistance of 29 ohms with a voltage of 13 volts with the experimental current of 0.45 ampere.
In this laboratory experiment called Ohm's Law, first we created a Zoom room for our meeting, and one of our members shared their screen and opened the simulator called Circuit Construction Kit and ran the lab activity. We then proceed to the table. The table is consist of 3 trials wherein the experimental voltage is held constant, which is 13 volts. On the first trial, the resistance is 3 ohms. The experimental current is 4.33 ampere. The theoretical voltage is 12.99 volts and the theoretical current is 4.33 ampere. On the second trial, the resistance is 16 ohms, the experimental current is 0.81 ampere, the theoretical voltage is 12.96 volts, and the theoretical current is 0.81 ampere. On the third trial, the resistance is 29 ohms, the experimental current is 0.45 ampere, the theoretical voltage is 13.05 volts, and theoretical current is 0.45 ampere. Brainstorming observation and conclusion out of this data, we are ready to input it on the template.
So for the table and computations, we have the computation for theoretical value, which are the voltage is equals to current times resistance, and current is equals to voltage divided by resistance. For our first trial, we have the resistance set into 3 ohms, experimental voltage set into 13 volts, that yielded experimental current of 4.33 ampere. For the theoretical voltage, we multiplied the 4.33 ampere into the 3 ohms, which is the resistance, that equates to the value of 12.99 volts, which is our theoretical voltage. And to get the theoretical current, we then divided the 13 volts to the 3 ohms, which is the resistance, that resulted to 4.33 ampere. Proceeding to the second trial, we have our resistance set into 16 ohms, our experimental voltage set into 13 volts, and that yielded the experimental current of 0.81 ampere. We then solved for the theoretical voltage, which is to multiply 0.81 ampere to 16 ohms. That equates to 12.96 volts. For the theoretical current, we then divided 13 volts into 16 ohms, which resulted to 0.81 ampere, which is just the same to the experimental current. And for our third trial, we have the resistance set into 29 ohms and experimental voltage set into 13 volts. That yielded the experimental current of 0.45 ampere. For the theoretical voltage, we then multiplied the 0.45 amperes into 29 ohms, that resulted to 13.05 volts. Current is equals to, or the theoretical current is equals to 13 volts divided by 29 ohms, which resulted to 0.45 amperes, which is just the same with the value of the experimental current.
Ohm's law is defined as an essential rule for analyzing circuits which involves voltage, current, and resistance in the simplest cases. The purpose of this experiment is to check and verify Ohm's law. which states that the potential difference is directly proportional to the resistance and that resistance is inversely proportional to the current. This relationship is often presented as the equations V equals IR and R equals V divided by I. From the data gathered, we can see that an increase in resistance is the decrease in the current, and the decrease in resistance is the increase in the value of electric current. For trial 1, we have a resistance of 3 ohms with a constant experimental voltage of 13 volts that yielded a current experimental value of 4.33A. On the theoretical value, the value of voltage is 12.99V and current is still 4.33. In trial 2, the resistance is 16 ohms that has the same experimental voltage in trial 1, which is 13 volts, with an experimental current value of 0.81A. Its theoretical value is at 12.96V and the theoretical current is at 0.81A. Lastly, in trial 3, the resistance value is 29 ohms with the same experimental voltage in trial 1 and 2 with 13V. The experimental current is 0.45A and the theoretical voltage is at 13.05V with a theoretical current of 0.45A. What we can infer from this is that as the resistance value increases, the current value, may it be experimental or theoretical, decreases.
Ohm's law is among the most fundamental relationships in electrical engineering. It relates the current, voltage, and resistance for a circuit elements so that if we know the two of three quantities, we can determine the third. We have observed that as the value of resistance increases, the value of electric current decreases, and that voltage stays just the same. Experimental and theoretical values of voltages and currents are not far from each, or we can say that they are 99.9% accurate. Thus, if we measure the current flowing in a resistor of known value, we can deduce the voltage across the resistance according to V equals IR. Similarly, if we measure the voltage across the resistor and the current through it, we calculate the resistance of the element to be R equals V or I.
The greater the value of resistors, the greater the value of electromotive force. This indicates the voltage range and resistor value are linear to each other while being perpendicular to the current value. Because of the steady slope, we can see that there is a clear relationship between current and electric potential. We can also see that there is an opposite relationship between current and resistance due to the exponential decay in the slope. Ohm's law allows you to determine characteristics of a circuit, such as how much current is flowing through it, if you know the voltage of the battery in the circuit and how much resistance is in the circuit.
Using the PET simulator, we can yield the experimental value of voltage, resistance, and current in a circuit. And utilizing the Ohm's law given computation, we can get the theoretical value of voltage and current as resistance is held to be the independent variable. And according to the data that we have gathered, as the value of the resistance increases for each trials, the voltage just stays the same, while the value of the current decreases. Then there is also a perceived difference if we'll increase the value of the voltage, for it also increases the value of the current. Experimental and theoretical value of voltage and current are almost the same, and are proved to be accurate. We can then conclude that the Ohm's law is proved to be true, that voltage is directly proportional to the current and that resistance is inversely proportional to the current, or when you multiply the resistance and current, it will give you the voltage. When you divide voltage to resistance, it will yield the value of the current.